In Onshape, you can create an assembly that consists of multiple components. Let's take a look at how to do that. Here I am in a part studio. It has multiple parts. It's got an engine block, it's also got the engine cover, and it has a muffler. But this is not an assembly. This is just a bunch of parts that were created in the same part studio, but I can leverage these when I create my assembly. And in addition to these three parts, I'm also going to include the engine head in my assembly. I've also got a crankshaft that I've created in another part studio. I've got a connecting rod and a pin that were created in the same studio, as well as the piston part. When you create a new document in Onshape, you will have an assembly that's created for you automatically, but if you want to make an additional assembly, you can go to the plus sign in the lower left-hand corner. Here we have the Create Assembly button, and here I have Assembly 3. Let's start bringing our components into the assembly. I will go to the Insert button, and you can insert parts and assemblies from the current document, from other documents that you have, or you can use standard content. And I'll do this at the end when I put in a few different fasteners. Let's go back to the current document, and so you can search if you happen to know the names of the components. But here I have the engine block. If I expand this, you can see the three parts inside of here. You can grab all the components just by selecting the name of the part studio, and you can see a preview. Now I'm going to immediately hit the green check mark. I'm not going to move the components around, so that way they will automatically be located at the origin of the model. But none of these components are fixed. So I'm going to select the engine block and then right click on it. In the pop-up menu, we can then choose Fix. And so now our first component is grounded. To avoid having to define mates to locate the engine cover and the muffler, I can create a group of components. It's a shortcut when you are leveraging a part studio with multiple parts and bringing it in. Let's go to the group command. And now for the instances, I will select the engine block and the engine cover and the muffler, then hit the check mark. And so in our mate features folder, we now have group 1. So all those three components are fixed relative to one another. So that was pretty easy. Let's bring in our next component. I will go to the Insert button, and I want the engine head. I'm just going to grab the individual part. You could grab the part studio if you want, but I'm just going to grab that one part. And this time when I move my mouse over the main window, you can see that it allows me to position the component approximately where I want to place it. Then I will left click in order to drop it. At this point, I could grab other components that I want to put in here, but I prefer to bring in a component or two, then add my different mates. So let's hit the check mark out of here. To add mates to locate this where I want, you have a bunch of different choices. I'm going to use a fastened mate for this one, but you also have revolute mates for 1 rotational degree of freedom. I will use that. Here is a slider mate for 1 translational degree of freedom. This one is for a planar mate, which has 3 degrees of freedom, I believe, 2 translational and 1 rotational. And also we have a cylindrical. We also have the one for a pin slot mate and a ball mate and a parallel mate. But anyhow, let's go to our fastened mate. And for the first mate connector, I'm going to move over and let it grab the mate connector that is inferenced at the center of this cylindrical surface. That is good. Let's left click on it. And then let me move over here, and I want to grab the mate connector for the middle of this circular edge. So I will left click, and it's located in there. It looks pretty good. Let me zoom in and take a look. Yep, everything looks lined up. I like that. So we can hit the check mark in order to commit to the current mate and start a new mate. Be aware that that brings us up to this one where we could start adding more mates inside of here. But I don't have any other new components to mate, so I'm going to cancel out of here. I could have just hit the green check mark out of that dialog box to begin with. So now that we have the engine head here in the model, I'm going to bring in a crankshaft that is going to rotate around the middle of the engine block. So at this point, it would be convenient for me to hide any of the components that I'm not concerned with at this moment. And so then we can go to the Insert button, and let's go to the Crankshaft Part Studio, and then grab the crankshaft part. And I'm just going to locate it up about over here to begin with, just so that it's not directly on top of the geometry that I'm going to use for the constraints, for the mates. And then I will hit the check mark. By the way, if you ever hear me say constraints, it's just because I'm too used to Creo Parametric. For the crankshaft, instead of using a fastened mate, we're going to use a revolute mate, which again is 1 rotational degree of freedom. And so I want to grab the middle of this annular surface, and what's going to be butted up against that is going to be this particular, let me move in over here. There we go, that looks good. Grab that, and it is in the model. It looks where I want it to be. Let's hit the check mark to close out of the Revolute Mate dialog box. Let's grab the engine block, right click on it, and make it transparent so you can see the crankshaft inside of there. If I want to see how this is going to move inside of it, I can right click on the Revolute Mate, then choose Animate, and here it's going to go between 0 and 360 degrees with 300 steps. Right now it's set to reciprocate. I want it to do it in a loop. I don't want it to go one direction then rotate in the other direction, because that's not how the crankshaft would work in real life. Then I will hit the play button, and you can see it rotating inside of here. So that looks good. That's the motion that I want for the crankshaft. So let's close out of the Animate Mate, and I'm going to leave the engine block transparent so it'll make it easier for me to bring in the next components. Let's go to the Insert button, and if I expand the rod and the pin, I want to bring in these 2 components, so might as well just select the Part Studio. Again, I'm just going to move them a little slightly out of the way so it's not overlapping on the geometry, and then hit the check mark. When I brought in an entire Part Studio before, I used the group command so that those components would be fixed to one another, but I don't want to do that in this situation because these components need to rotate relative to each other. If I try to group them, then they'll be fixed to one another and I won't get the motion that I want. So let's put in a couple of revolute mates. So I will go to the command in the ribbon, and then for the first mate connector, I'm going to let it, let's see if I can get it to, trying to get it right on the cylinder. There we go. I'm trying to get it right in the middle. There we go. Got it to inference into the location that I wanted. And then let's get it to the middle of this particular component. That looks good for that one. You'll notice when this one moved, it did not bring the pin with it. That's correct. That's actually what I want so far. And this time I will use the check mark here to commit to the current mate and start a new one. And so for this revolute mate, let's grab the middle of this cylinder and then grab the middle of that cylinder. And that looks good. Let's grab this little ribbon out of the way and hit the check mark. And so once again, we can, oops, let's cancel out of the other revolute. We can go to the first revolute and then animate it. And let's change this back to loop, hit the play button. And so you see that everything is rotating along with it. And that's okay for now. Everything will be fixed when I put in the piston with its different mates. So let's do that. Let's go to the insert button, and then I'm going to go to my piston and then grab that one, and let's just move it about over here and hit the check mark. And I want to show you a couple of incorrect ways that won't work first. Then I'll show you what will actually work. And I need to be able to select stuff in the engine block. So let's turn off the make transparent. And so for the first one, I want this to be able to go up and down inside of the engine block. So that's one translational degree of freedom. That would be a slider mate. And so let's choose the slider mate. And then for the mate connectors, let me grab the middle of this surface and grab the middle of this surface. So it repositions inside of there. That's good. Let's hit the check mark to complete the slider mate. And now let's go back and hide the engine block. And I need to connect the piston to the piston pin. And so I think to myself, okay, that should be what? One rotational degree of freedom. Let's try doing a revolute mate. And again, this is not going to work, but that's okay. So let's grab, say, the middle of this surface and then the middle of this surface. And right now they are coincident. I'm going to put in an offset, and let's try an offset of 2. And that's in the wrong direction. Let's try -2. And so I can take a look and say, oh, no, it's still too far on one side. Let's try -5. And that looks pretty good. That looks like it puts it right in the center of the piston where I want it to be. So I will hit the check mark, and you'll notice now we get this red in the list of the mate features. We have a mate error. And if I go back to, say, the slider and then go to the edit command, well, this is in red. And if I see here, it says slider 1 did not regenerate properly. This mate over-defines the assembly. So let's take a couple of steps back. Let's go to the revolute, and I will delete this one. And let's go to the slider and delete that one. Let me go back to the engine block and make it visible so I can select stuff. And so this time, rather than using a slider mate for the piston to the engine block, I'm going to use a cylinder mate. And that'll give me a situation where I won't end up over constraining, over defining my mechanism. So let's go to the cylinder mate. And for the mate connectors, let me grab the middle of the engine block and the middle of the piston itself. That's good. And I'm going to hit the check mark for a moment just so that I can hide the engine block. And let's put in another cylinder mate. And this time I will choose this surface, middle of that surface over there, and it adjusts. Let's hit the solve button. You'll notice that the position adjusted automatically to put the piston in the middle there. I will hit the check mark, and now we don't have red this time. So if you find yourself in a situation where it's saying that you're over constraining your mechanism, hey, try to use a different mate that has more degrees of freedom. So rather than using the slider with one translational degree of freedom and the pin with one rotational degree of freedom, I used 2 cylinder mates with 2 degrees of freedom, one translational, one rotational, and that made everything work. So let's bring back the display of the engine block, but I will make it transparent, and let's test the motion now. Let's go to revolute 1, right click on it and choose animate. And again, change the playback to loop. And then we will hit the play button. And hey, that looks beautiful. I can see that the crankshaft is turning, which is causing the connecting rod to rotate itself, which is then connected to the piston pin, and that's moving the piston up and down inside of the engine block. So this is exactly the kind of motion that I want in my assembly. I am very happy with this. So let's close out of the animate dialog box. Let's close out of the transparency. Let's bring back some of our other different components. And the last thing I'm going to do in here is put in some standard hardware. So let's zoom in over here. So for example, I want to fasten the engine head to the engine block. Let's go to the insert button and I will go to standard content. And right now it's set for ANSI inch. Well, this one should be in ISO. And I want to put in some bolts and screws, and you have different drop-down lists. I want to use a socket head screw. That's good. I can use this to auto size the fastener and then pick the edge. And so here's giving me a size of M12. And so for the length here, it's 120. That's a little long. I happen to know that I only need about 2.5 inches, which corresponds to about 60 millimeters. So I'll change the thread and the thread length. And then so before I hit the insert button, if I leave my mouse over here, I should get a little tooltip. It tells me that to insert the standard content and add a fastened mate, we can pre-select edges or faces and then click the insert, or you can select a planar face, or you can click insert and then drag the standard content in the model and let it snap. Well, I prefer to pre-select, so I'm going to grab this edge. So you can see the little one attached to my cursor. Let's grab that one. Now we have 2 edges selected. Let's grab that one. And we have 3, and then grab this one. So now we have 4 selected. Let's hit the insert button. And so now I've got all of those fasteners in here. And let's put in another one while we're at it. So again, let's go to the auto size. I think these holes are the same size, but I just want to check to be sure. Okay, the component has been sized to M12. That is good. And for the length of this one, I think I need it a little less. Let's go to a length of 50. And this time for the insert, I'm just going to pick one of the edges, and you can see a preview in there for how it's going to be placed. And then I'm going to hit the check mark because I want to show you an alternate tool for getting additional ones in there. And the alternate tool is this command for replicate. And you can read the tooltip that explains how to use it, but let me show it to you. I'm going to click on the replicate command, and then you'll pick the instances for the components that you want to replicate. So I will pick this fastener that I put in there, and then we can match edges on the face or on a plane, or match individual edges. I'm going to do edges on the face. Let's click in the collector for faces to find match in, and I will pick this surface, and there it automatically selected the other 3 holes. That's good. Let's hit the check mark. So wrong direction. Everything looks good, and you can see how our assembly has been populated with our various different components. You can still see the mate connectors for the standard content. Let me expand one of those fasteners, and here we have the near mate connector listed in here. I can right click on it and I can choose hide all mate connectors, and I'll turn off the display of all of them. So in that way, I have my assembly created. It's got its mechanism motion, and it's got some of the standard hardware that I need. And very last thing to finish this off, let's go to the name of the assembly, right click on it and choose rename. And I will call this the engine assy and hit the enter key. and that renames it at the top of the instances list, as well as the tab inside of my document. I hope you enjoyed this video. For more information, please visit www.creowindshield.com. If you learned something from this video, please give it a thumbs up. And if you like this video, please click the subscribe button and ring the bell to be informed when new videos are uploaded. Thank you very much.